Anyway, also, by using that highly stabilized supercooled liquid, we can get the X-ray diffraction patterns over the whole temperature range, liquidus temperatures, the glass transitions, and the room temperatures. And so that the, of course, that the viscosity increases with decreasing temperatures. And this is a liquidus temperature. This is a room temperature. You can notice a significant difference. And the main peaks, that's a width, this is a broad, and that's the narrows and the very high intensities. And that's these sub-peaks also develop at room temperatures, indicating that the development of short range and medium range ordered atomic configurations during the cooling. So accompanying with that the significant increase of the viscosities. From this, so we can point out the key point of formations of BMGs is attributed to the control of mainly icosahedral-like network atomic configurations, atomic clusters on a long-range scale. So these BMGs can be regarded as ultimately typical nanostructured materials obtained by utilizing the spontaneous atomic configurations in the stabilized multi-component alloy liquid with the three-component rules. Now, so I'll show you that some engineering properties very briefly. And so that in comparison with the conventional crystalline alloy, you can see the Glassy alloy shows a much higher tensile strength and much lower Young's modulus and much larger elastic elongations. The difference reaches as large as about 3 times. And when we choose just for one example, zirconium-70, zirconium-rich alloys, quaternary alloys, shows a very high Poisson ratios of 0.387. And we can get the centimeter class bulk samples even for the 70% zirconium. And this alloy shows a very good, high compressive ductilities. Therefore, we examined the tensile deformation behaviors by using the high-speed video camera. And that's we can record, we were able to record the load and displacement during the tensile deformations. And when we assume the thickness of shear band is about 15 nanometers, from these relations, we can estimate that the viscosity is 3.8 times 10^3 Pascal second. And so that's the temperatures reaches about 840 kelvins, which is much higher than the glass transition temperatures, just inside the shear band under tensile plastic deformations at the room temperature. Anyway, this is at the 70 zirconium-70 alloys. This alloys also shows a much better corrosion resistance than that for the pure zirconium metals in sodium chloride solutions. Also, we didn't get any degradations of tensile strengths evaluated by slow strain rate testing, indicating that these alloys shows a high resistance to the stress corrosion cracking in sodium chloride solutions. Also, this alloy shows zirconium-rich alloy shows a very high fracture toughness of 110 megapascal root meters, and high levels is maintained even after annealing treatment. So, as you know, that the Glassy alloy shows a glass transition and the supercooled liquid regions. In this So supercooled liquid regions, we obtain the Newtonian viscosities as well as ideal superplasticities. Therefore, we can get the very large tensile elongations, in this case more than 10,000%. And that's the supercooled liquid of glassy type R shows that the continuous decrease in specific volumes with decreasing temperatures in good contrast to the significant shrinkage due to solidifications for conventional crystalline. Therefore, we applied the suitable load to supercooled liquid of glassy type alloys. We can obtain the mirror-like images between the copper mold surface and the glassy alloy surface on the nanometer scales, indicating the very good imprintability of BMGs. So here I summarize the application field that have been proceeded at present in Japan. So that's the bold-faced letters represent that these materials have really gained application field. I'll show you that some examples. So that's the golf clubs, driver iron patterns, were commercialized by Dunlop corporations in Japan, and glassy alloy mirrors developed by Canon corporations, and that's the connecting parts like the ferrules for optical fibers were commercialized by YKK corporations. And this is the casing, but we didn't obtain the real applications for this material, just testing something anyway. But this one is really commercial. That's micro-geared motors consisting of these glassy alloy parts produced by net casting process. And 3-stage geared motors with diameters of 1.5 millimeters per 1.5 millimeters and 3-stage shows a very high torques, which is about 20 times higher than those for the conventional vibration motors for our cell phones. That's a very high torques. And you can buy this one. And now that's the companies is Namiki Seimitsu Corporation. And that's the companies wanted to reduce further to the diameter 0.9 millimeters, which can penetrate into the blood tubes of our human bodies. And these micro-geared motors have been tested for applications of advanced medical equipment, precision optics, micro industries, and micro factories. So you can, as you know very well, that's these bulk glassy alloys show the unique properties, higher tensile strength, and lower Young's modulus as compared with the stainless steel. And we can produce that the pressure diaphragms by net casting process. And this glassy alloy diaphragm shows that the very high sensitivities and higher pressure zones and super small sizes as compared with the conventional stainless or cobalt nickel pressure sensors. And by using the ZrACuNi casting, you can get that glassy alloy pipes with a very thin thickness of 0.2 millimeters. And this glassy alloy pipe shows a very high sensitivities as a Coriolis flow meters, because that's a lower Young's modulus and large elastic elongations. And this is a real outside view of that what is a wave motion drive type Coriolis mass flow meters. And you can notice that the sensitivities is much higher than those for the conventional stainless steel flow meters. Therefore, just tested, not commercialized, tested in the field of fossil fuel, chemical, and the environmental industry field. And also titanium bezel without nickel element has been tested as plates and screws for fixing bones and tooth implants. And also, Glassy alloy shows us good transmission properties with low attenuation. Therefore, these BMG tips has been tested to the ultrasonic appliance in dentistries. And also, we prepared this kind of tweezers, BMG tweezers with brilliant sharpness and hyperfine designs. Just also that have been tested. So, in order to achieve that the future sustainable societies, it's very important to develop the iron-based Glassy alloys with highly functional properties. Since the first synthesis of iron-based Glassy alloys in 1995, we developed a variety of iron-based Glassy alloys. Some iron-based have already gained real application with the trademarks of ZrACuNi, Centix, Galois, and Amobiz. You know, the iron-based Glassy alloys shows a good combinations of lower coercivity and higher electrical resistivities because of much lower internal stress caused by the more homogenized atomic configuration. So that's for ZrACuNi, commercialized by Alps Electrical Corporation. That's the consolidated magnetic coils can be produced in a very simple process of the production of powders by water atomizations and the mixing of powders with resin and cold consolidation and annealing. We can get this kind of magnetic coils. And this coil shows nearly constant relative permeabilities in a wide frequency range, the good linear relations between permeability and magnetic applied current, and very much lower core losses as compared with other soft magnetic materials. So in comparison, manganese zinc ferrite and sanders, you can notice that the ZrACuNi has an advantage point. Therefore, so ZrACuNi powder coils has been commercialized as power inductors in the desktop type personal computers because of higher efficiencies and lower heat of generations. And also, ZrACuNi powders can be deformed into the flaky shapes. When we mix the flaky shapes with resin, we can get the ZrACuNi seed. This seed shows a very high conversion ratios from electromagnetic noise to heat. We can get the highly efficient noise suppression property because this ZrACuNi seed shows a higher real permeabilities and imaginary permeabilities in a high frequency range of over 500 megahertz as compared with sandust seed. Therefore, the ZrACuNi seed has been so commercialized in various kinds of electromagnetic devices. Also, ZrACuNi seed has been so commercialized as a radio frequency identification system. So that's the ZrACuNi seed. When we inserted between the metal parts, real electromagnetic device parts, and the loop antenna, magnetic flux lines can enter into the antenna. We can get the significant increase of antenna sensitivities at a carrier frequency of 13.56 megahertz. And because that the ZrACuNi seed shows a much higher quality factors defined by the real permeabilities to imaginary permeabilities as compared with sandust seed. And when you open that's mobile phones. That's you can find that radio frequency identification system using that Glassy alloys. So in addition to the applications of notebook, personal computers, or our cell phones, now we have been challenging to applications of the hybrid vehicles and electric vehicles. That's like the automobile. That's a big challenge subject. So anyway, we are challenging. Also, another type of soft magnetic, Centix, has been commercialized by NEC Talking corporations. And the use of these inductors can reduce more than 50% core loss from existing metal powders, can save thermal issues at personal computer board, and can extend battery lifetimes of not personal computers by 10% since 2009. So this Coils has been commercialized by NEC Talking corporations. And that's the final part is, iron-based alloy shows a very high fracture strength and large Young's modulus and high hardness, and also high fatigue strength, over 2,000 megapascals after 10 million cycles. And we also developed mass production techniques of iron-based Glassy alloy balls. So that is commercialized by Shinto Industry Corporations and AMOBs. These AMOBs shows a much longer endurance times up to final ruptures as a shot pin balls as compared to cast steel shot and high-speed steel shot. And also, this AMOBs has another advantage of high protectivity against explosions as compared with steel shot and stainless steel shot. And therefore, these AMOBs have been applied to generate the high compressive residual stress of over 2,000 megapascals and to increase the fatigue strength by 80%. And we can reduce the material's weight by 45%, for instance, high class of automobiles gears, alloy steel gears. So by using the high velocity of oxygen-free spray coating techniques, we can get the iron-based Glassy alloy coated layers, and we can use various kinds of substrate materials. This coated layers shows a better corrosion resistance than that for stainless steel and higher because hardness than that for hard chromium plate. And by bending test, Japanese industrial standard bending test, so we didn't observe any abrasions and swellings after bending in the bending regions. And also, this coating layer shows that the good wear resistance in comparison with the hard chromium plating and chromium hydride coating. Therefore, this Galois coating, that's the trademarks. Galois coating techniques has been commercialized by that's Topi Industries.